the writer goes this far to say that the difference between legacy code and non-legacy code is that the code which is covered with test is a non-legacy code, and the code which is not covered with any test is a legacy code. And there is a big dilemma. When we change code, we should have tests in place, and in order to have tests in place, sometimes we have to change code. Hello friends, welcome to the video. And in today's video, we learn some important aspects about refactoring legacy codes according to the famous book Working Effectively with Legacy Codes by Michael C. Feathers. So refactoring differs from general cleanup of code, in which we are just doing low risk thing like code cleanup or code reformatting, and it differs from high risk thing like completely rewriting implementation as well. So instead, in refactoring, we make small structural modifications to the code supported by tests so that to make the code easier to be changeable in the future. So in general, while doing refactoring, we can make three types of changes to the code. We can change the structure of the code, we can change the functionality of the code, and we can change the resource usage or the memory usage of the code. The big deal while doing refactoring is that we ourselves don't know how much functionality is at risk when we make our change. Preserving existing behavior is one of the largest challenges that we face while doing refactoring. Even when we are changing some primary behaviors, there is a large area of application behavior that we need to preserve while making these changes. So, in software development, it is a common saying, if it is not broken, don't fix it. So when we avoid creating new classes and methods, the existing ones become larger and difficult to understand. So the difference between good systems and bad ones is that in a good system, once you have done your learning, you feel very calm and confident in making your changes with respect to the fear of breaking any existing behavior. Whereas in a poorly structured code, the move for figuring things out to make changes feels like jumping from a cliff to avoid a tiger. And as said in the common saying, if it is not broken, don't fix it, avoiding code changes has other bad consequences as well. When people don't make changes to the system very often, the overall system becomes kind of a rusty. And one of the other consequences of avoiding change is fear. Unfortunately, many teams live with this fear of change, and it gets worse every day by day. So there are two approaches that you can take while refactoring your code. The first is edit and pray, and the second is cover and modify. So when using edit and pray, you carefully plan the changes that you are going to make. You make sure that you understand the code that you are going to modify, and then you start making the changes. When you are done, you run the system to see whether the changes that you made are enabled or not. And then you poke around any further to make sure that you haven't broken anything. This poking around is pretty essential. It is essential for the safety of the system. But safety doesn't really come by just being careful. I don't think any one of us will use a surgeon who uses a butcher knife just because the surgeon is very careful while using his butcher knife. Effective software change, just like an effective surgery, requires more deeper skills than just being careful. So, working with care doesn't do much for you until you use the right tools and techniques. So, this is why cover and modify is a more effective technique. The idea behind it is that it is possible to work with a safety net while making our changes. It is like a cloak that we put on the area that we are making our changes so that the bad changes don't leak out to the rest of the software. And covering the area that we are modifying with a cloak means covering them with proper tests. So when we have covered the area that we are trying to change with a good set of tests, we can confidently make our changes and find out quickly whether the effect of our changes was a good one or a bad one. So suppose we start to refactor our code a bit. We extract some method and we move some conditional logic. After every little change that we make, we run our little suite of unit tests and they pass almost every time we run them. But a few minutes ago, we made a mistake. We inverted the logic in a condition and one of our tests started to fail. But because of this immediate alarm sign by the test, we are able to revert our mistake pretty quickly, maybe in a minute or so. This way, when we do our refactoring, our code is much cleaner and clearer. We make the changes we are set out to make, and we are confident that our changes are the right changes because we added some tests to verify this behavior. So, the next programmer who comes in to work on this piece of code will have a relatively easier time, as he will have the tests which is covering the functionality already. So, this is why unit test is a very important aspect when it comes to refactoring legacy code. In fact, the writer goes this far to say that the difference between legacy code and non legacy code is that the code which is covered with test is a non legacy code, and the code which is not covered with any test is a legacy code. So, last test which test the complete system, they're generally called regression tests. They are great, but these small tests which test the individual units at generally at class level, they are invaluable. They give you feedback as you develop and allow you to refactor with much more safety. So, one of the biggest problems while writing tests or refactoring in general is managing dependencies. Much legacy code work involves breaking dependencies so that making changes can be easier. And there is a big dilemma. When we change code, we should have tests in place. And in order to have tests in place, sometimes we have to change code. While writing tests and while refactoring, we usually have to break dependencies between classes at some place. When we break dependencies, we can often write tests that make more invasive changes safer. And the trick is to do this initial refactoring very conservatively. Being conservative is the right thing to do when we can possibly be introducing errors while making our changes. But sometimes when we break dependencies just to cover our code with test, it doesn't turn out as nice as what we expected it to be. We might be introducing parameters to methods that aren't strictly needed in production code, or we might break apart classes in odd ways just to get tests in place. And when we do that, we might end up making the code look a little poorer than what it originally was. So when you break dependencies in a legacy code, you often have to suspend your sense of aesthetics a bit. Some dependencies break out cleanly, whereas others end up looking less than ideal from a design point of view. But they are like incision points in a surgery. There might be a scar left in your code, but everything beneath it will be working in a better way. And if later the area where you broke the dependencies, if you are able to cover that area with some tests, it is like healing the scar as well, whereas the below things are already performing better. So friends, these were some philosophies that we learned from the book Working Effectively with Legacy Code. Hope you would have liked our explanation of these philosophies. And as always, we request you to like our video, share it with as many people as you can. If possible, take a screenshot of the video and share it on your social media like Twitter, LinkedIn, Facebook, whatever you may prefer. And please show us your love by subscribing to our channel and liking this video as well. Thanks a lot for watching.